Let's upload one more time and be confident it's going to work. Clean it. A. So every 2 seconds it's printing A. And you see, you haven't written any serial begin, serial print or anything, and you are getting data in the serial port. And what is that port? The 0 and 1. So okay, so in the last video we saw that how to switch on and off an LED, or how to send 0 and 1 from a pin. And this video we are going to discuss using that how can we send the letter A. We already tried in the previous video, but I said there are two mistakes. Number one is you have to first tell computer I am going to send you something so that he is ready, and that is the bit number. This first bit you have to make it 0, and then followed by you have to send the whole data, and finally you have to send another bit called 1, bit 1, which says that I am done. So this first start bit and end bit you have to add, and also you have to be very precise about how long each bit will last. The width of each bit have to be fixed and agreed upon both the party. So how the code will look like in C++, let's see. So when you wrote in the PictoBlox something like set signal to high or low, in the lower end in the C++ code it looks like digitalWrite. There's a function called digitalWrite. We send low, and this is how it works. So okay, let's not think about how to send the signal. Just know that you're sending a low voltage, and then you have to wait for a fixed time. You have to delay for a fixed time as long as you want this low to last, I mean the bit width, and then after that you send the high signal. Wait for again the same fixed time. What is the fixed time will come. Then you again send low for consecutive 5 times, and then you send again a high signal followed by the fixed time again, and then you send a low and then send high. Looks okay, right? But there is a problem, because we thought okay, anyway I'm sending a low, and then throughout this whole time it's going to be low. Why should I explicitly send a low signal? And I was not sending. That could be a disaster. Why? I'm not going into that details, and if you're interested we can talk about it later. But for now you just know that even though it's very implicit, it's already 0 and it's not going to change to high until you say. Still you have to insert this low in middle. So this is how the letter A will literally look like, and when you will be sending to computer it's going to write it for you. And how? Let's see. So I'll come back to PictoBlox one more time, and it was in wait a minute. So this was the last attempt we had, and I'm going to delete this whole attempt. And because we need to be very precise on time, I'm going to switch to upload mode. In upload mode I can directly write raw C++ code. What I want to send I can write directly here. Now let's come to the point, how much delay I should provide. So it is like we have to agree on. So let's see what PictoBlox supports. PictoBlox supports in 1 second I can send this many data, or in 1 second I can send 9600 data. So each bit, how much will be the size? So for that I will bring pen, and this is how it will look like. So you have to take the whole 1 second, and then you have to say how many pieces I have to break, and each piece will be 1 bit. So this is 1, this is 0, I mean this is 0, so this is 0, 0, 0, 5, 0, and then 1. So what will be this bit length is decided by this 1 second interval, how many pieces you are breaking, and this is what that number is. This is called Baud Rate. So 9600, let's take for example. So if I break this whole 1 second into 9600, how much comes in 1 bit? So for that, let me take a calculator, and do a simple division. 1 divided by 9600, and it's come around 1.04. so we can take it at 1.04 and we can omit the other things as a approximation, and this is second, so I can say it a millisecond, 104 millisecond. So let's declare a variable called bit duration 104. so I'll say int bit duration equal to 104. It's a millisecond. Okay. So, or better to be more explicit, like Python always say, be explicit. So 1 divided by 9600. Let him find out what it is. So that's all. Now come back to the pin position. So we need to find out which pin I want to use. So if I use pin number something other than 0 and 1, then I have to take care of something what I don't want right now. So let's not to concentrate on what I'm doing here. Just know, if you understand already, you know that transmitter and receiver pin are already 0 and 1 in your Arduino. So if I use the pin number 0 and 1, which is already assigned for the serial communication, so now I want to transmit from the Arduino, so I have to use the TX, means pin number 1. So pin number 1 I have to program for all this sending purpose. So I will use the pin number 1 and I will send the whole series of A in a loop. So before that I have to prepare the pin, right? So I will say pin mode in capital, pin mode for 2 and its output. So it's a output pin when I'm sending the signal out. Okay, and then I am going to send a digital write W caps pin number 2 as high. Why I am sending it high? Because when we send continuous high signal, that means we are not transmitting any data. So you have to by default keep this line always high. That's the rule of UART. Okay, UART works like that. If you come up with your own custom rule, that will be different. So delay 1 second. This is just to prepare it and not directly to jump into the loop. So for that is a hard-coded delay. You can keep it 1 second or more than 1 second, doesn't matter. Okay, so coming back to the main point now. So now I'm going to send the signals. Send start bit. So first I want to send the start bit, not the A itself. I'm sending the start bit, which is digital write pin number 2, and I'm sending a low. So it was high and then I'm bringing it to low to tell, hey, I'm going to send the data. And then there is a catch. So delay, if I send a delay and pass this bit duration into the delay, it will not work because this is a microsecond and we want microsecond precision. So that's why we, and then sorry, this is not int, this have to be float. And so we can do one more thing. We can declare it as a float, or you can even directly define as define bit duration as the final value. I don't want to play with the floating points, that's why I'm doing this. So 104, that's what the calculator value, right? Where's the calculator? Yeah, 104. So 104. Now this delay will not work because the delay will work on millisecond, but we are working on microsecond. So delay microsecond. So delay microseconds will take the bit duration, or let me directly write down just to be more explicit. Okay, so I want to give delay of 104 every time. So this is the low signal, this is not the real data I am sending. Now it starts. So okay, this one comes with this, now it starts. So I want to send first of all a high value, because A starts with 1 then 4 not. So this one is I am sending actually 1. So what I will do is I just write it 1, okay, just to remind us that we are sending a value 1, and then just delete this 1. Now it's have to be 0, right? So we are sending next bit as low, and duration is same. So 1 0 2 0 3 0 4 0 5 0, 5 zeros, and then I am going to send one more 1. That's what A is, but here it not ends. As you know, you have to send a stop bit also. So this was a start bit, so I have to send a stop bit as well. So I'll keep it little far from the main data so that you don't mess up with that. Yeah, so start bit and stop bit have to be high. So that's what the agreement with. Okay, so I will, yeah, stop it. That's what the agreement in UART. So now you send this. What else you need to do? Nothing, just flush the code. So now it will be so fast you cannot see what's going on. It's already in the pin, but it will be so fast you will not be able to know what's going on. But leave it. Let's see if computer can read the A. That's what we want, right? Let's see what happens. Upload the code, and it's asking to connect. So I will connect one more time. Pin number is 1, then flush the code. 16 20 32, come on. So this time it's uploading the full code, because it's in upload mode. It will not do a half code inside, half code outside thing. And now I am getting something in my serial pin. Oh my god, what is that? It's coming and not coming. What's that? Oh, so we have chosen the baud rate as 9600. So let's take 9600 and it's connected. So let me reset once the Arduino, let it get reconnected, and it's still not able to detect. So what's the problem? What is the problem? So better to send a delay in middle so that it doesn't treat this as a next signal and mess up with something else. So I will flush this code just to tell him that give enough time to him so that he will understand the alphabet is done, whatever is sent is done. And now let's see what happens. Now let's see, where am I? Okay, I'm here. Okay, now let's see, let me reboot this once. And it's connected only, and nothing is coming. So what could be the reason? What is the pin we are using? Pin number 1. And what is the pin we are writing here? Pin number 2. Oh my god, that's a disaster. So that's where this variable gets handy. So we have to write it pin number 1. Whatever we write there, it will be reflecting everywhere. So this is the mistake. I could have done a live YouTube videos series so that you could have found this flaw and I could have not wasted this much time. Okay, let's see. Let's hope for the best. And then it's doing, sending, upload done, and voila. Hey, what is that? Only one A came, and then it's not sending. What's that? But at least one A came, right? It's a ray of hope. Reset. Again. What's wrong with that? So let me check. It's sending some blah 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 before sending the A one more time. No, it's only sending only once A, and then that means initially everything was good for the first bit, and then something went wrong. What went wrong? Aha, that's the problem. We have to bring the bit to high, because that was the initial state, right? When you are not sending any data, you have to keep it high. So you see the debugging, and the hint is here. Only once it printed. That means when it's entering first time in the loop, it was all perfect, and then something happened at the end which end up in the disaster, so that after that onward the loop is not printing it. So that should be at the end somewhere, or into the Arduino, or somewhere else. So, and we are already seeing some problem is here, and that should be the one. Let's upload one more time and be confident it's going to work. So why I'm showing this Arduino, I don't know, but yeah, see this. Clean it. A. So every 2 seconds it's printing A, and you see you haven't written any serial begin, serial print or anything, and you are getting data in the serial port. And what is that port? The 0 and 1. So I am not using even the port number 0. It's empty. Just the port number 1 is there, and that is the transmitter, and I am not using the receiver, and still it's working full-fledged. So that's the power of serial communication, binary number system, and many things. So hope you enjoyed this, and stay tuned, because something more exciting is going to come. Using the same serial concept, we are going to do something more radically different, and stay tuned. Keep watching the video and subscribe and support a bit. Thank you. Bye.